So, hello friends, again I am here to teach you one of the important topic of transform technique, which is Fourier transform. Fourier transform is very important topic in terms of engineering applications because it is very useful. Using transform technique, already we are changing time domain function into frequency domain, and because actually we can't work on time domain, so we have to convert every function to use it in engineering field. We have to convert it into frequency domain. Not only in that point of view, actually when you go for to solve any partial differential equation, which is very useful in terms of uh, heat equation, wave equation, or transmission lines, it will play very important role. Fourier transform. Using Fourier transform, you can solve that very easily. Same like Laplace, using Laplace transform, you can solve ordinary differential equation easily. Uh, so let me start, and I will teach complete Fourier transform one by one. So first of all, in this video, I am going to teach you just what is Fourier transform, and how we find out Fourier transform of any given function. Then in next video, definitely I will go for Fourier sine transform and Fourier cosine transform and the properties. Same like as in Laplace transform, we have several properties like change of scale property, shifting property, uh, and convolution theorems, Parseval identity. So same everything here. So that will I will teach in next video. So in this video, just I'm going to give a overview of how we calculate a Fourier transform of given function. So let me start. So Fourier transform. So suppose a function ft given or fx, either it will given in terms of x or t, it's not matter. Fx given, then Fourier transform of fx is denoted by minus infinite to infinite fx e to the power iota sx dx. So every time one function fx will be given or ft, and you have to calculate its Fourier transform. So how we calculate Fourier transform? Just put the value of fx here and integrate. Here, same like Laplace transform, you have to know how we calculate inverse Fourier transform, because when fx given, you using this formula you can calculate Fourier transform of fx, and it is denoted by f of x, where s represent frequency. Now inverse Fourier transform. Inverse Fourier transform means now fs will be given, and how we calculate fx. Same like when you study in physics modulation and demodulation. Modulation means we are imposing a modulating signal to a carrier signal, and then again we have to do a demodulation. So same type here, when we have fs means a signal in frequency domain, how we convert in time domain. For that purpose you have required inverse Fourier transform. So what is inverse Fourier transform? That is fx is given by 1 upon 2 pi minus infinite to infinite fs e to the power minus isx ds. So don't be confused. If you see in some books, coefficient multiplication is different. Someone using 1 upon root 2 pi here. It's not matter. It will not affect anymore. You can use this one. Some of writers are using e to the power minus isx here and e to the power iota sx here. So it's not a matter. So this is the main formula. When fx given, you can calculate fs by using this formula. Then using inverse Fourier transform, you can calculate fx when fs given using this formula. So your main work depends on integration. If you know integration little bit, then please go and finish that part integration, because integration here play very important role. Any transform technique, either it is a Fourier series or Laplace or Fourier transform, it will contain integration. So integration play important role here. Only Z transform is a function, a transform technique where discrete signals are there, so their summation play important role, which we will see later. So hope you understand. Fx given, you have to calculate fs, and when fs given, you have to calculate fx. Sometimes it will play important role to calculate the value of integral. I will try to do that type questions also. How we calculate the value of standard integral using this technique. Easily we can do. So now I'm going to write one question. Suppose fx given 1 if mod x less than equal to a and 0 if mod x greater than a. And the question is find Fourier transform of fx. So same type question, always one fx will be given to you and they ask you to find Fourier transform of fx. So how we calculate? Now fx given, see the fx value is 1 when mod x less than equal to a. What is the mean of mod x less than equal to a? It means x lies between minus a to plus a, and value is 0 when x value greater than a. So what is fs? Minus infinite to infinite fx e to the power iota sx dx. Now see the fx. Fx defined only for x value mod x less than equal to a, means x lies between minus a to plus a. So only for this value, value of function is 1. For remaining every value is 0. So what is your fs? Integration minus infinite to infinite becomes minus a to plus a. What is fx? 1 e to the power iota sx dx. For remaining all values of x, it will be 0. Now integrate. You know integration of e to the power ax dx. It is e to the power ax upon a. So use the formula. What we get? E to the power iota sx upon iota s limit minus a to plus a. It means 1 upon iota s outside, it is e to the power iota sa minus e to the power minus iota sa. If you know simple hyperbolic function, then if we multiply 2 here, so s e to the power iota sa minus e to the power minus iota sa upon 2 iota. This is nothing formula for sine as. So this is Fourier transform of that function. Uh, what is sine as? In terms of exponential, its value is e to the power iota sa minus e to the power minus iota sa by 2 iota. So this is the final answer. If you left here also it is correct. But what happened? Sometimes for integral, if they ask some standard, then it will be create some problem. So you have to simplify. Nothing, it's very easy. So now we will do one more question. So hope you understand this one. Suppose in next question, what they ask, they given fx same and they ask find the value of 0 to infinite x dx. Then how we calculate? So whenever in Fourier transform they ask you to evaluate integral, what is your first rule? First rule is find Fourier transform, then calculate inverse Fourier transform. Using inverse Fourier transform only, we have to calculate integral value. So please take care this thing. Now come for this one using Fourier inverse transform. What is the formula? Fx is 1 upon 2 pi integral minus infinite to infinite fs e to the power minus sx ds. So just put the values. What is fx? Fx is nothing but 1 0 1 if mod x less than equal to a, mod x greater than a. What is right hand side? 1 upon 2 pi minus infinite to infinite. What is fs? Fs is nothing but 2 upon s sine as e to the power minus iota sx dx. So 2 cancel. Pi will come this side. So what is the value? Pi 0 if mod x less than equal to a, if mod x greater than a, and this side minus infinite to infinite sine as e to the power minus iota sx dx by s. So So now we have to calculate integral value of 0 to infinite sine x by x. So see, a value we required how much value 1, because a is arbitrary constant, we can take anything. So take for a value 1, what we get for a value 1, same result, pi 0 if mod x less than equal to 1, if mod x greater than 1, integral minus infinite to infinite sin s pi s e to the power minus iota x ds. Now friends, what is required? We required 0 to infinite sin x by x dx. So it means what value of x we will choose? Take x value 0. Then what happened? If we choose x value 0, then definitely this term will becomes 1. And when x0 means it lies, what is the value? X0 means this one. What is the value? Iota pi is equal to minus infinite to infinite sin s pi s ds. This means because sin s by s is an even function, because sin is odd, s is odd by odd means even function. So you know fx is even function if f of minus x is equal to fx. So sin s by s is an even function, because in place of s if you put minus s, then sin minus s is minus sin s, and again denominator is minus s, so minus minus cancel, same function we will get. So it's an even function. What is the value? Use different integral property, it becomes twice 0 to infinite so what is the integral value? Is nothing, pi by 2. This is very important result and standard also. So you understand, hope. So what is our role? Our role is very simple. If in question they ask find the Fourier transform, then just use the formula and calculate. Suppose they ask integral value, calculate integral of this. It means they ask you to go for Fourier inverse transform, and using that you have to calculate integral value. There you have to choose x value depends what you required. Sometimes you have to go for comparison, because e to the power minus iota sx, it is nothing cos sx minus iota sin sx. So both the side real to real and imaginary to imaginary you have to calculate. So based on what they ask in integration, you have to think. I will try to explain different type problems and we will do. Now my next question is very similar to this. What is that? My next question is, suppose fx given this time x 0 when mod x less than equal to 1 and when mod x greater than 1. Now the question is Find its Fourier transform. So now I think you understand the methodology. It's very simple. Fourier transform of fx is nothing minus infinite to infinite fx e to the power iota sx dx. Just put the values. Again, here x valid from -1 to 1, value is there. For remaining all values, value is 0. So integral limit from -1 to 1 only. For remaining all values of x, it is 0. And what is fx? X e to the power iota sx dx. Now my friends, you know how we calculate integral, correct? Integration by parts, correct? First into second. Which one first? Using Euler formula, algebraic term will come first and exponential will come last. So this is your first and this is your second. What is the formula? Formula for integration is first into second integration, first same to same integration of second minus d by dx of first integration of second and then whole integration. Limit, I will tell how we can minimize the errors, that I will explain here. So first function same to same e to the power iota sx integration e to the power iota sx upon iota s minus x differentiation 1, its integration e to the power iota sx upon iota s dx. Limit, it's -1 to 1 x e to the power iota sx upon iota s minus again integration iota sx upon iota s whole square. Limit -1 to 1. Now we have to simplify. Simplify means just in place of x put values 1. So it is good if you do separately. In that way you can minimize the errors, because in Fourier series Laplace transform and here integration, when you put limits, chances of errors is maximum. So better you will do separately. So when x value 1, what is the limit? We put I1. I1 is what? E to the power iota s upon iota s minus e to the power iota s upon iota s whole square. Now I2. I2 means when we put limit -1, what is the value? Minus e to the power iota s minus upon iota s minus iota s whole square. Now this integral value means, what is your I? What is your Fs? I1 minus I2. Subtract. So e to the power iota s, when you subtract it is become plus e to the power minus iota s upon iota s in one bracket. This is plus e to the power minus iota s minus iota s upon iota s square. So if you remember, this is what? E to the power iota theta plus e to the power minus iota theta by 2 is the formula for cos s theta. So it is cos s 2 multiply because 2 required upon iota s. This is e to the minus times e to the power iota s minus e to the power minus iota upon 2 iota. So 2 required, 2 multiplied, 2 here. So 2 sin s upon iota s square. This is your fs value. So here what we used, cos s is nothing e to the power iota s minus e to the power minus iota s plus by 2, and sin s is e to the power iota s minus e to the power minus iota s upon 2 iota. So again we, if you want, we can simplify this one, otherwise you can leave here.